Hello and welcome back to Beginning Java Programming. This week we're going to be talking about methods. So kind of like a variable as a way of giving a name to a piece of data. A method is sort of a way of giving a name to a set of instructions, right? I've got a procedure. I've got lines of code that I want to execute, and I may want to do this repeatedly. Well, I don't have to write my code repeatedly. I'd rather give it a name, and then I can just call that function. Or call that method. I can just, say, hey, do this, and it will know I need to just go to where that method is located and do all of those lines of code. And then I can sort of make something that's a little bit more modular, right? It makes sense. Like if I have the same login procedure for a website or a web application of some sort, and like I may want to change that in future. It would be so much easier if I just had that code in one place, and when I wanted to make a change, I could just make it in that one place, and then just everywhere else where I actually have somebody log in or ask somebody to log in, I just call that bit of code. Creating that modularity is really, really good design when it comes to computer programming, right? Back in the old days, we didn't have, I shouldn't say back in the old days, before I was born, before 1969, and sort of the development of the C language, we had what we called spaghetti programming. You followed lines of code, you jumped over to another set of lines of code, you jumped over to another set of lines of code, you may jump back to this set of code. But what you're really doing was creating little sections of code where it was like, oh yeah, I just know that this is where I do that thing. And so I always have to jump to that location in order to execute those lines of code. Functions are just a way of encapsulating that in a much better way. But even more than just giving a name to a set of instructions, right? Functions also have the ability to perform like functions do in mathematics. If you ever took a math class and you heard about the function machine, right? Usually depicted as something sort of a big funnel at the top, almost a meat grinder. And you can put values into the function machine and it does some stuff to it and then it pops out this value. Functions have a way of doing that. They have a way of taking in input and providing output. And so, if you ever got to a point in your math class where you got to the part where it's like the f of x equals 2x, right? What is that doing? What is that saying, right? And you'd have this thing where so what's the f of 3? Well, the f of 3 basically means that I'm going to take that 3 and I'm going to substitute it in for x in the f of x, and then, I'll do 2 times 3 instead of 2 times x, and so the answer will be 6. So that f of 3 becomes kind of poof and becomes a 6, right? In your little, you'd cross it out, you'd write a 6 there. And you might have another function g, right? And g just squares something. So the g of x equals x squared. So if I took a 3 and I were to, do the g of 3, I'd end up with 9, right? They're sort of basic functions, but what am I doing? I'm really defining a generic function, right? The f of x equals 2x. What does that mean? It just means that the function f doubles things. That's all it does. It just doubles stuff. The g of x, what does g do? The g just cubes stuff. These have terrible names because mathematicians are bad at naming things, right? But f and g are just functions that are defined to do something to a value when you send it to them. Functions for us are going to work in the exact same way. And by the way, I'm going to have a little bit of sort of pedanticness here about the naming of things, because you're going to notice that I say methods and functions almost interchangeably. They're not. But in Java, everything is a method, and that's because Java requires all their code to be inside of a class, and that's actually what defines the difference between a method and a function. So a function is kind of what we're describing, right? What I'm describing are functions. If a function belongs to a class, it's called a method. So functions are just functions that belong to a class. But function is the more generic term. It's kind of like if anybody's ever told you that, unless it comes from the Champagne region of France, it's actually just sparkling white wine. It's not champagne. It's the same thing. Sparkling white wine is the generic term. You could call anything sparkling white wine. Technically, Dom Perignon is sparkling white wine. It is. Happens to come from the Champagne region of France, so you call it champagne, right? Same thing with methods. Methods are functions. They're just functions that belong to a class. We haven't talked about classes because we haven't gotten to object-oriented programming yet. And that's the negative of Java, is that you sort of start having to put things in classes and put things in functions or in methods. But because Java requires everything to be in a class, that means that all of the functions in Java are methods. And so we generally just say method for all functions, because in Java, all functions are methods. But it's a small thing. The other is going to be, when we talked about the f of x, analogy. When I use the f of 3, and I'm actually trying to call the function, right? I'm trying to actually turn this into a value, evaluate something. So the f of 3, that 3 is an argument that I'm sending to the function. When I'm defining the function, the f of x equals 2x, that x there is a parameter. It is receiving the argument that it's being sent when the function gets called, and then, essentially, I'm just assigning that value, so now x has the value of 3, and so 2x is going to be 6, right? So arguments are something you send when you call a function or a method, and the parameter is when you're defining the function, it's what's going to receive that argument. All right, so let's get started and actually try to create some of these methods. Hopefully you at first realize that we've been using a method this entire time. Our main method is a method just like any other method. It is a name that we've given to a set of instructions. We have put all of our instructions inside of main, and that's because main is a special method. It is the first method called by the system whenever your program is run. But it is structured much like any other method. So let's say I want to create my own method, something that I can use to, let's say, cube a number, right? So I'm going to make my method by first starting out with a couple modifiers. So modifiers are keywords that will modify sort of the options of our method. Consider this like the settings or something. For this week, you're going to use the exact same 2 modifiers for everything. Eventually, it'll make more sense, when we get to object-oriented programming, what these actually do. But the first part is public. This is just an access modifier that basically says what code can actually call this function and use it. By default, methods are private. So for a method to call this function, it would have to be part of the main class where it's defined. We are inside of the main class right now. Any code outside of that couldn't call it. And so we're going to use the public keyword so that anybody can call it. Although, strictly speaking, we're just going to test it here in main. So main is a member of main. Lowercase main, the method, is a member of uppercase main, the class. So it would have access anyway. But regardless, public makes a little bit more sense. The other one is static. This really won't make sense until we get to object-oriented programming. But in general, static means that the method is going to be associated with the class rather than an instance of the class, rather than an object from that class. Eventually, you'll learn that classes are like templates that we can use to make objects later, like individual objects. But for right now, we don't want to have to create instances of objects or instances of classes. So we're just going to call it static so that we can make it as just a standalone function. You'll see here this print line method, right, that we've been using for a while. It's actually not static. It is associated with this out object. And so in order to use the print method, you have to have that out object. Print needs some of the other data and functionality that's encapsulated into that object in order to be able to do its job. We're not going to do that. We're going to do some simple mathematical stuff, so we're good. And then the next part, this will actually matter and make sense. Remember how I said methods can take input and return output? Well, what is the type of output that I'm going to get from this method? This is our next thing. It's the return type. It's really kind of like the type for the method. In other words, when I make a method call and I say the f of 3, right? If you can picture me using the f of 3 in an expression, and you can kind of picture, you either scratch it out with your pencil and write in an answer, or it kind of goes poof to you and it gets replaced with that answer. What is the type of that answer? Is it an integer? Is it a double? is it a string, right? Maybe f actually is just selecting from a list of names or something. F of 3 is, oh, return a string with the name of the third state adopted into the United States. I don't know. But like, whatever that is, we need to know that type. Is it a string? Is it an integer? Is it a whatever? Now, I mean, theoretically, there's no reason I couldn't take doubles. We can cube doubles. We can cube integers. A cube of an integer will always be an integer. So if I only took integers, I could return an integer and we'd be just fine. But I'm going to go ahead and be a little bit more daring. This is going to return a double. So that's the next part. We've got our modifiers, public static for everything at this point. Later on, you'll be able to customize that. And then what is the return type for this method? The next thing is going to be the name of the method. So I have to call it something. It cubes numbers. I think that's probably a pretty good name. In all honesty, I think sometimes the hardest part of computer science is just naming things. So, regardless, we have a name, cube. That name is going to be important because we're going to use that name whenever we call this function. Now, not all functions will take input, but if we want to take an argument from a function call, we have to have a parameter to receive that value. Right? Really, this is just like a variable. Parameters are just variables that will be assigned a value when you call the function. So here, we said we're going to return a double. That means we're probably going to take a double. And so we'll take a double. We have to give it a name. This is going to be the name of the variable. Just like I'm creating a variable anywhere else, right? I have to say double something, right? I could put num if I wanted to. For really, in general, I do not like single letter variable names unless it's very clearly defined mathematically. So if you're talking about what's the area of a circle, using R for radius is perfectly fine. Like that is an established mathematical definition. Calling it X would not be fine, right? Because X is not the traditional thing that we use to define a radius. In fact, X has a different value in math. It has it's the X coordinate on a Cartesian system. So in general, don't like single variable names, prefer more descriptive names. Here, I could probably just go in and be fine because it's just going to be a number of some sort, but I could be more creative if I wanted to. Now, this is going to be before I get to the brackets, the parameter list is always in parentheses. And you can have more than one parameter if you want, right? You could take a double and then maybe another double. You could have it take an integer as well. I don't know why I chose O. L, M, N. I'm kind of messing with the order a bit, but regardless. And so you can take as many as you want, just separate them out by commas. But then when you call the function, you're going to need to send all three of those parameters. For cubing, it doesn't make sense. You can cube one number, so I'm just going to choose the one parameter. Now, by the way, functions do not have to take parameters or provide output. They may just simply do work, kind of like main does. Main here technically takes this string array called args, and that's just because our template is set up for command line. And so command line will often take arguments to calls to programs. It's kind of hard to explain. Here, maybe I can just show you. If I pop up my terminal, so again, this template was for a command line tool. So here I've got, my thing with apparently an update from Apple. But regardless, I've got my command line. If I want to hit ls, that will list all of the files and folders in my home folder, right? Not a big deal. But that ls is a program, and in command line you can actually send arguments to that program. So ls minus l, for instance, will say list everything but do it in long form. So that minus l could be sent to my program and received by main. That just means give me more information. Who's the owner? When was it last modified? And what are the permissions for the folder? Don't worry about any of this. Point being, we never use this in sort of modern non-command line programming. So it just sits there. But main really doesn't take or doesn't use anything that it takes, and it doesn't provide any output. So you'll notice that here the return type for main is void. If you want to, you can actually have this return void. And if you want it to take nothing, you just leave the parentheses blank. Because you can't leave this blank, because then it'll try to read cube as the return value, because perimeters or parentheses are kind of nice delimiters. It's fine, but we'd have to put void here. You just leave this blank. You actually, I think, can put void in here as well. It's not necessary. No, apparently in Java you can't. That's a C++ thing. Anyway, point being, we are going to undo, because we do want to take an input and return stuff. Now, after this, and I would call this the function header, right? Has sort of all the information about the function, what it's going to take, what it's going to return, all that sort of stuff. Then we have these parentheses or curly braces. Those curly braces are delimiters. I place mine up here and then a closing one here. Notice how everything that's inside the class is indented one indent. And then we have our curly braces. And then everything inside of those curly braces is going to be indented one more indent. So we know that it's inside that method. The more you can keep stuff organized and lined up, the easier your life is going to be. Sometimes just missing a curly brace can totally break a program, and it's just because there's a curly brace missing or it's in the wrong spot. But regardless, anything inside those curly braces are going to be the lines of instructions that we want to execute whenever this method is called. And we could do anything we want, right? We could say, yo mama, that's fine. We can do that. We could have it access a server. We could have it do something else. You can do a whole bunch of additional work in addition to returning something. But at some point, you're going to want to return what you said you were going to. This method returns a double. And in fact, that's what this little red squiggle is telling me. Missing return statement. It's only missing a return statement because I said I was going to return something and I haven't yet. So what do I need to return? So I will use the keyword return followed by an expression. That expression will be evaluated. And that expression, once it's evaluated, wherever you called this function, that's where you can kind of picture like you're scratching it out and replacing it with that value. And so here I want to cube in. Well, cubing in is just n times n times n. Done. I now have a function that will cube a number. If you give it a number, it will cube that number. It will also insult your mother. I don't know why I added that, but you can. You can do additional work other than just returning something. And so now, instead of in main, because remember, this is the main function that gets called. So if I want to test this, I'm going to have to test it here in main. I'm going to have to test maybe for the cube of 3. Now you'll notice that IntelliJ is popping in this little in thing here, which, okay, had I chosen a more descriptive name, then this would have been a little bit more descriptive for my users, but that's fine. But I'm going to print out the cube of n, and if I run that program, hopefully we will get the answer 9, unless I am terrible at math and not realizing it. Taking a while, build. And there we go. We get the answer. Oh, sorry. Hi, I am terrible at math. 3 squared, I usually do squared, not cubed. I don't know, I'm mixing stuff up for no reason. 3 squared would be 9. 3 cubed would be 27. So we are correct. And we got 27.0 because we did return a double, not an integer, even though I sent an integer. It's treating it like a double. And my mother was insulted for no good reason. We could just comment that out if we wanted to. Commenting out just means putting those 2 slashes in front of it so that it doesn't get read as code anymore. But the idea is there. We've created a function definition, right? That has defined what cubed means, and now I can use it anywhere in my program. Now, here's going to be a temptation for people. Some people are going to want to do this. Oops. And then, well, this would have been easier. I just typed it, but it's fine. They're going to want to print out those values rather than return them. See, that doesn't help. Although here, all I'm doing is printing out. The printing is really just, it's a function of how I want to use the cube, right? If I were to do this, I would get the same result, right? I mean, I'd have to switch this double to void to make it actually compile. But like, it would say 27.0 here on the screen. But that's all I could do. The only thing I could do was with cube would be to print a cube value. Printing out values doesn't do me a whole lot of good. So I'm going to undo. All right, I'm back to my original return version. The nice thing about this is I can do something like 2 times the cube of 3. Because this actually returns a value, this is going to return 27, right? I can use that in an expression to create other values, right? I could say 2 times the cube of 3, which would be 54, right? Yeah. It's very late. My math is slipping. Yada, yada, yada. Yeah, there we go. 54.0. So, like, we've got the ability to actually use this expression into other expressions. In fact, we can even use it as an argument to another method. This would be something kind of like nesting. So this is the cube of 3, right? So this would be this innermost one gets done first. So we cube 3, that returns 27. So you can picture scratching that out with your pencil and writing a 27 in there. That 27 then gets sent as the argument for another call to the cube function. So now it's going to be 27 cubed, which I'm going to be honest, I'm just going to have to assume this is right. I have no idea what 27 cubed is. I mean, I could pull out a calculator, but this is a computer, it is a calculator. I'm going to assume that 19,863 is the correct answer for 27 times 27 times 27. But you get the idea. Because those functions return something, I can actually just use them in larger expressions to get the results that I want. And that is basically what we're doing this week. We are defining some methods that will do some basic tasks. And again, you can have methods that return something that is like a string or whatever. You can have it do whatever. Yeah, so there you go. Methods. If you have any questions, be sure to contact me at some point this week, and I'd be happy to help.